At the center of our galaxy lies a monster 4 million times heavier than our Sun, an object that swallows light and bends space itself. This black hole, Sagittarius A*, commands the orbits of 400 billion stars, shaping the Milky Way from the shadows. Time slows, space twists, and stars race at millions of miles per hour just to survive. If you're ready to face the most extreme physics in the universe, prepare yourself. We begin. Welcome to the mystery of Sagittarius A. From Earth, the Milky Way appears as a pale streak of light stretching across the night sky. For ancient stargazers, it looked like a river of milk or trail of fireflies. But what they were really seeing was a vast disk of billions of stars woven together in a spiral. At its brightest point, the galactic center, lies a swollen bulge of starlight. And behind it, something far stranger. For centuries, astronomers could not see what was there. The center of the galaxy was blocked by immense clouds of interstellar dust, tiny particles of rock, carbon, and ice left over from the deaths of stars. These grains scatter visible light, just as smoke blocks a flashlight beam. Early telescopes, which relied on visible light, were helpless. The heart of the Milky Way remained a mystery. As scientists built better instruments, they noticed hints that something unusual was happening. The stars near the galactic bulge didn't move like stars elsewhere. They seemed to orbit around an invisible point. But no one knew what that point was. Some believed the Sun itself was the center of the Milky Way, while others thought the galaxy had no true heart at all. It wasn't until the 20th century, when astronomers began using radio waves and infrared light, that the fog began to lift. Unlike visible light, these longer wavelengths can pierce through cosmic dust. Suddenly, the hidden heart of the Milky Way started to reveal itself. And in that heart, astronomers found a mystery, a compact, incredibly powerful source of radio energy coming from the constellation Sagittarius. They named it Sagittarius A. At first, it was just a strange bright spot in radio maps. But over time, it became clear that this was no ordinary object. Something massive, invisible, and extraordinary was waiting at the center of our galaxy. In the 1930s, a young engineer named Carl Jansky was working at Bell Telephone Laboratories. His job wasn't astronomy, it was problem-solving for radio communications. Long-distance radio signals kept getting interrupted by strange static, and Jansky was tasked with tracking down the source. To investigate, he built a rotating antenna, nicknamed the merry-go-round, that could sweep across the sky. What he found shocked him. Some of the interference came from thunderstorms on Earth. Some came from distant lightning. But one repeating signal seemed to come from the stars themselves. Every day, it rose and set, but not exactly on a 24-hour solar schedule. Instead, it arrived 4 minutes earlier each day, just like the stars. Jansky had stumbled onto the first detection of cosmic radio waves, and their source, the direction of the constellation Sagittarius, right at the heart of the Milky Way. Though Jansky's discovery was revolutionary, it wasn't fully appreciated at the time. Astronomers of the 1930s were still focused on visible light, and the idea of listening to the sky in radio waves felt bizarre. Jansky eventually moved on, and his work was nearly forgotten. But in the 1940s, an amateur radio engineer named Grote Reber picked up the trail. In his own backyard, he built the first true radio telescope, a parabolic dish 9 meters wide. Reber mapped the sky in radio frequencies and confirmed Jansky's discovery. At the galactic center, a powerful radio source burned brightly. By the 1960s, With better instruments, astronomers could pinpoint this mysterious beacon more precisely. It was small, compact, and steady. They named it Sagittarius A, but as the data improved, it became clear that Sagittarius A itself contained something even stranger, a tiny, hypercompact region that radiated enormous energy. This became known as Sagittarius A star. No star, no nebula, no known object fit the description. Something new was hiding there, something powerful enough to pull stars into rapid orbits, but invisible to the eye. Visible light had failed. For centuries, the galactic center looked like a smeared blur of stars and dark streaks. But in the second half of the 20th century, astronomers discovered a new way to see through the curtain: infrared light. Infrared wavelengths are longer than visible light, which means they can slip through dust more easily. Telescopes sensitive to infrared suddenly revealed what had been hidden for millennia. Behind the black streaks of dust lay dense clusters of stars, glowing gas, and a furious heart unlike anything imagined. In the 1980s, astronomers began placing infrared telescopes on mountaintops in Hawaii and Chile, where the thin, dry air allowed clearer skies. Later, they launched them into space. Satellites like the Spitzer Space Telescope mapped the center of the Milky Way with stunning clarity, showing a core brimming with stars. But even more intriguing, they spotted stars whipping around something completely dark. Two teams, one led by Reinhard Genzel in Europe and another by Andrea Ghez in California, began painstakingly tracking these stars. Using adaptive optics, which corrects for the blur of Earth's atmosphere, they followed their orbits year after year. These stars were racing at thousands of kilometers per second, pulled by a gravitational monster that emitted no light. One star, known as S2, became the smoking gun. Its orbit took just 16 years to circle the invisible object. By mapping its path, astronomers calculated the mass of what lay at the center, about 4 million suns packed into a space smaller than our solar system. The conclusion was inescapable. The only thing that could explain such density and gravity was a supermassive black hole. Sagittarius A* was no longer a mystery signal. It was the beating dark heart of the Milky Way. Imagine a cosmic ballet, with stars as dancers moving at impossible speeds. That's what astronomers witnessed in the 1990s and 2000s as they tracked the so-called S-stars orbiting Sagittarius A star. S2, the brightest, swoops incredibly close to the black hole, just 17 light hours from the center, a tiny distance in cosmic terms. At its nearest point, it hurtles through space at over 5,000 kilometers per second. That's fast enough to reach the moon from Earth in a minute. These orbits told us more than just the black hole's mass. They also became a direct test of Einstein's general relativity. As S2 passed close to Sagittarius A*, its orbit shifted slightly, a subtle warping of space-time predicted by Einstein a century earlier. Both Genzel's and Ghez teams measured this effect with exquisite precision, confirming relativity once again, in one of the most extreme environments possible. Over the years, more S-stars have been tracked. Some move in long, looping paths. Others plunge dangerously close, skimming the edge of the point of no return. Their behavior all points to the same conclusion. At the center of the Milky Way lies a black hole millions of times the Sun's mass. For this work, in 2020, Genzel and Ghez were awarded the Nobel Prize in Physics. Their decades of patient observation had given us not only proof of Sagittarius A*, but also a window into how gravity behaves in the most extreme laboratory nature provides. Watching these stars is like seeing shadows dance around a fire you cannot touch. The fire itself remains invisible, but its power shapes everything nearby. Sagittarius A** revealed itself not by light, but by the motion of those bound to its grip. When scientists talk about black holes, they don't mean just one type. Sagittarius A* belongs to the class of supermassive black holes, but there are others, smaller, larger, and stranger. The smallest are stellar mass black holes, born when massive stars collapse after supernova explosions. They can pack a few times the sun's mass into a sphere just a few kilometers wide. We've found dozens of these scattered through the Milky Way, often detected by the X-rays they emit as they feed on nearby stars. Rarer are the intermediate black holes, weighing hundreds or thousands of suns. Their origin is still mysterious. Perhaps they form in dense star clusters, growing slowly as they swallow their neighbors. Some astronomers think they could be the missing link between stellar remnants and galactic giants. Then come the supermassive black holes. These behemoths, like Sagittarius A*, contain millions to billions of solar masses. How they form is still an open question. Did they grow slowly, eating gas and stars over billions of years? Or did some appear suddenly in the early universe, collapsing directly from massive gas clouds? And there are even stranger possibilities. Some theories predict primordial black holes, relics of the Big Bang itself, formed from density fluctuations in the newborn universe. If they exist, they could range from the size of a mountain to the mass of a star. Compared to the monsters in distant galaxies, Sagittarius A* is on the modest side. Some supermassive black holes weigh tens of billions of suns and blaze as quasars, outshining entire galaxies. Ours is relatively quiet, feeding only occasionally. But this quietness is a gift. It means we can study Sagittarius A* up close, without the blinding glare of constant activity. It is a laboratory for gravity, magnetism, and the extreme physics that define the cosmos. Black holes are often imagined as cosmic vacuum cleaners, devouring everything in sight. But the truth is more subtle. Sagittarius A* is surprisingly quiet. Unlike the blazing quasars in other galaxies, our black hole feeds only sporadically. Gas and dust swirl near the event horizon, but much of it never falls in. Magnetic fields, turbulence, and high-energy winds push most of the material away before it crosses the point of no return. This low appetite makes Sagittarius A* dim. In fact, if it were brighter, we might have discovered it centuries earlier. Instead, it flickers faintly in radio, infrared, and X-rays, with occasional bursts of activity. Astronomers have seen sudden flares, brief flashes of light as clumps of gas spiral inward and heat to millions of degrees. In 2019, the black hole grew brighter than ever before observed, likely after swallowing a particularly dense blob of material. But most of the time, it slumbers. This quietness also shapes life in the Milky Way. If Sagittarius A* were an active quasar, the radiation pouring from the galactic center could make large regions of the galaxy hostile to life. Instead, its calm has allowed stars, and planets like ours, to thrive in relative peace. Yet its past may have been wilder. Evidence suggests that millions of years ago, Sagittarius A* flared brightly enough to create enormous bubbles of gamma radiation, still visible today above and below the galactic plane. Perhaps our black hole once blazed like a quasar, only to fade into its current drowsy state. For now, we live beside a sleeping giant, one that stays occasionally, reminding us of its hidden power. For decades, we knew Sagittarius A * only through its effects, the motion of stars, the radio signals, the occasional flare. But could we ever see it? The challenge seemed impossible. The black hole's event horizon is about 24 million kilometers wide, vast by human standards, but tiny compared to the 26,000 light-years that separate us from the galactic center. From Earth, it appears as small as a donut on the moon. To capture it, astronomers needed a telescope the size of Earth itself. So they built one, virtually. The Event Horizon Telescope, EHT, is a network of radio observatories across the globe, from Hawaii to Chile, Spain to the South Pole. By synchronizing them with atomic clocks, they created a planet-sized eye sharp enough to glimpse the shadow of a black hole. In 2017, the EHT turned towards Sagittarius A star. Processing the data took years, as the swirling material around the black hole shifted constantly. But in 2022, the world finally saw the result. The first image of our galaxy's central black hole. A glowing ring of radio light encircling a dark shadow, the silhouette of the event horizon itself. It wasn't a crisp photograph, but it was revolutionary. For the first time, we weren't just inferring the existence of Sagittarius A star. We were looking at its outline, its very shadow against the universe. The image joined the famous picture of the black hole in galaxy M87, captured a few years earlier. Together, they confirmed Einstein's predictions and opened a new era of black hole astronomy. Sagittarius A *, once invisible, now had a face. Why does the Milky Way and nearly every galaxy we know have a black hole at its center? The answer is still unfolding. The mass of a galaxy's central black hole seems to link with the mass of its bulge of stars. Somehow, the growth of one influences the other. Black holes may regulate the birth of stars, shaping the life cycles of galaxies themselves. In this sense, Sagittarius A * is not just a hidden monster. It may be the architect of the Milky Way. Its future, too, is unwritten. Billions of years from now, when the Milky Way collides with the Andromeda Galaxy, their central black holes will spiral toward each other and merge. The result will be a black hole far larger than Sagittarius A *, dominating the new galaxy that forms from the collision. Until then, Sagittarius A * continues its quiet reign. It is both destructive and creative, swallowing matter, bending space and time, yet also anchoring the galaxy we call home. Studying it teaches us about the most extreme physics in the universe, how gravity warps light, how stars survive near oblivion, and how galaxies evolve over billions of years. It reminds us that even in silence, immense power can shape the cosmos. At the center of everything, hidden in darkness, lies a truth. The universe is stranger, deeper, and more mysterious than we can imagine. Sagittarius A * is our local proof of that cosmic wonder. And so, at the very heart of our galaxy, the mystery becomes clear. What was once only a faint radio whisper, hidden behind veils of dust, has revealed itself as a supermassive black hole, Sagittarius A star. It is silent, yet powerful, invisible, yet shaping the destiny of everything in the Milky Way. We've watched stars dance around it. We've captured its shadow with a planet-sized telescope, and we've begun to understand how it influences not just the galactic center, but the very structure of our cosmic home. But even now, questions remain. How did it form so quickly in the early universe? Why does every galaxy seem to hide a monster of its own? And what will happen when ours finally awakens again? or when it collides with Andromeda's black hole billions of years from now. Sagittarius A asterisk reminds us that the universe is never finished telling its story. There are always deeper mysteries waiting just beyond the veil. If you enjoyed this exploration, don't forget to like, subscribe, and share, because there are many more cosmic stories waiting to be told.